एक मिनट रुकना। अच्छा चलिए ठीक है, ये यहाँ से हम स्टार्ट कर लेते हैं कि वी गोना स्टार्ट विद अच्छा सो वी आर गोना स्टार्ट विद पहले वो क्विक रीकैप उसका, ठीक है, फ्रैगमेंटेशन। रिमेंबर ये पेपर का था, सो वी गोना डू दिस वन। जस्ट a very quick recap इधर ही कर लेते हैं कि I have fragmentation is कि when you do mass spectroscopy a lot of tiny fragments are produced, ठीक है, that's what fragmentation is. So by just looking at the fragments you can figure out कि for example I just give you, there were two questions, there were very basic questions on this. Okay, they told us that NH4NO3 was heated and it decomposes and produces a certain gas. So there's this gas X, and this gas X when mass spectroscopy was done, these particles were detected at these mass to charge values. So you got a detection at 14, you got a detection at 16, you got a detection at 28, at so you got one at 28, then 30, and then you also got one at 44. So उसने कहा था identify these particles, right? So whatever gas is produced, it's being produced from this thing, right? So it's so 14 would probably be the nitrogen fragment, right? 16 would be the oxygen fragment. The smallest ones are the simplest ones. They're easy to identify. 28 kya hoga? 28 would probably be 2 nitrogens, N2 plus 1. 30 would be NO plus 1. 44 would be N2O. So that's your molecular ion. The heaviest fragment is the molecular ion, ठीक है? Is that clear? And we also had a difficult question, which was they told us to draw the whole structure of this thing. You had SiX, CLY, and oxygen was Z. So they were asking us to draw the structure based on the fragmentation pattern, that the smallest fragment, there were no isotopes. So silicon was 28, Cl was 35, and oxygen was 16. So they told us that the fragmentation pattern, you got different detection at these mass to charge values. There was a smaller fragment of 133. There was a bigger fragment at 147. You got a detection at I think that's 147. I think that's 149. You got a detection at 247. You got a detection at 263, and then you finally got the heaviest detection was at 396. You had to figure out what the structure was. You just know that whatever was present, the smaller pieces were just a combination of SiCl and oxygen. Okay? So you just had to figure out what combination would give you 133. That's going to be 1 Si and 3 Cls. And what would be 149? That's going to be a bigger piece of this molecule. So 133 and 149, the difference is 16. So it's just going to be a bigger piece of the molecule. It's going to have an oxygen. 247 is going to be an even bigger piece. So something else must be part of it. That's going to be 1 Si and 2 Cls. That's going to give you 247. 263 will have an extra oxygen to it. So it's going to be an even bigger piece. And 396 has a difference of 133. So that is an extra Si and 3 Cls added to it. I mean, these, as far as I can recall, these are the only two questions that I've seen. Is that clear? I mean, there might be other ones.
जो structure आपने बनाया है, तो is it necessary कि हम exactly मतलब
in this case they were actually expecting exactly this one. This was the difficult one. Well, previous one was kind of easy. They just told you that that was a lot easier. Okay, so you don't. Plus, there's another thing about fragmentation, that you can identify isomers based on the fragmentation pattern. Like if I have a molecule C3H6, let's say I have figured out that it is C3H6. Okay, so So the fragmentation pattern can help us identify which C3H6 it is. Okay, it could be different isomers. You could have an alkene that could be C3H6. So this one will have 3 H's, or it could be a cycloalkane, right?
So, लेकिन अगर if it's a fragmentation, तो फिर it must have a charge.
नहीं, ये सारों के ऊपर charge होगा ना. That's going to be charge. It should have a charge.
वैसे charge overall compound पे होता है ना?
नहीं, one of them is the molecular ion. That's the overall compound. That's the heaviest one. Okay, the whole thing is intact and it has a charge. If you were looking for 133 would be Si with 3 Cls, right? Like when you write it, it's going to have a charge because in mass spectroscopy, you only detect charged particles, right? Is that clear?
लेकिन ये charge specific atom पे कि overall compound पे?
Oh, on the overall thing. On the overall thing. Remember, the charge is always on the overall thing most of the time. Okay. But the other thing I was talking about fragmentation was, I mean, these are two things. TK, you have to remember. The other thing was, okay, based on sometimes what will happen is that you know that it is C3H6, but you don't know which one it is. Is it this one? Is it this isomer, or is it this isomer? So the fragmentation pattern can also help you identify this. Because what will happen is, especially in this case, you'll detect a CH3 particle, a fragment in this one, but you will not detect a CH3 fragment in this one. That's not going to happen. Is that clear? So you will be, so if you're getting a detection at 15, that would mean that it definitely has, it's this structure, it's not this structure, because that structure over here is not capable of forming a fragment or a piece. I mean, you break it anywhere, that piece is not going to be 15. Is that clear?
Yes, sir.
बस ये fragmentation में दो चीजें हैं, ठीक है? You'll be able to identify, it might help you to identify the isomer, which one is it, or me,
if we have like a fragment that's, let's say, a CH4, like a fragment that's complete that doesn't have any missing bonds, do we still put the positive charge on it?
The fragment will always, if the fragment is getting anything that is getting detected by the mass spectroscopy, that will have a positive charge, no matter what it is. It's going to have a positive charge.
Yeah, okay, yes.
I said, like, the fragment would always be incomplete. It's not going to be a complete. I mean, if you break it into pieces, the piece would always have incomplete bonds. So the fragment by default cannot really have complete bonds because it's a piece of the bigger molecule. So its bonds would be incomplete. Is that clear as well?
G, क्योंकि neutral one would not be detected then.
नहीं, एक तो वो charge वाला है ना कि it's got to be a charged particles. That's why it's going to be detected by the mass spectrum, right?
Yeah.
The other thing was that I said that it can't be silicon with 4 hydrogens, right? Because the fragment will always have incomplete bonds. Because if a piece breaks off, that piece of the bigger molecule it's not going to have complete bonds. Is that clear?
Yeah. Clear.
So, so let's get reverse. We'll start with the last one. This is which paper? Summer 20 question paper 4-1. So I'm going to start with.
Actually, sir, excuse me. Before start this paper, we may done the yesterday question of 21 October number 41. Question number 2, part 3, part 4, sir. We may again done it, sir, to start this paper.
I'll do it at the end. Okay.
Okay.
I would have to open it.
Okay.
My laptop is slowing down, so okay.
Okay.
सर एक क्वेश्चन है कि ये फिनाइल इथेनॉल ब्रोमीन वाटर के साथ रिएक्ट करते हैं?
Phenyl? No, it won't.
इथेनॉल
नहीं, क्योंकि phenols react with किधर है हमारा ये एक सेकंड दोनों खोल लेते हैं एक ये वाला just a second. Phenol, remember, reacts with वो activated benzene जो है ना, that's phenol.
सिर्फ एक्टिवेटेड बेंजीन में तो हमारे पास NH2 का ऑप्शन भी है, NO2 का भी है.
नहीं, NO2 is not. NO2 is deactivated. So just one second. just remember, okay, you need to have where's phenol? This one. Yeah. Bromination happens with phenol, okay, where the OH should be directly bonded to benzene. Q, because the lone pair on the oxygen over here will mix with the benzene electron cloud, and the electron cloud would become more negative, and that is why it's going to attract electrophiles very, very strongly, okay? But alcohols are not going to react. Okay, is that clear?
Alcohols, okay. Sorry.
Well, if you have a carbon chain and then there is an OH, then it's not a phenol. It's a simple alcohol.
Or sir, CH3 अगर attached to alkyl chain.
किसके साथ?
इसी के साथ. I mean, instead of OH, you have a CH3.
No, that's an arene. Then it's this one, right? Arenes have a reaction. You have chlorination or bromination, but you need a catalyst for that because the carbon chain has an electron donating effect, but they don't have lone pairs. So the charge density doesn't really increase that much. It does increase, but it doesn't increase that much. So you still need a catalyst in that case. ठीक है, is that clear?
Yeah, take it.
लेकिन sir, if we have a ketone, तो उसकी वजह से withdrawing effect नहीं होगा?
नहीं, किस केस में? When do you have a ketone?
जैसे अगर बेंजीन है उसके साथ कीटोन हो और फिर
नहीं, पहली बात है, it's not in your course. First thing, okay, you don't have that in your syllabus. That it's going to be a withdrawing effect, but we're not talking about ketones at the moment. We're talking about benzene having an OH group or benzene having a carbon chain attached to it. ठीक है?
ठीक है, ठीक है.
But benzene having a ketone attached to it, that's not in your course. So let's start with this. So let's start with this paper. Okay, that's the last question. So question number 10. As I predict the likely oxidation state of element Q, 3D4S2. What is the likely oxidation state of element Q? What is that element? Okay, we would need the data booklet. What is 3D24S2? That's scandium, vanadium. That's probably vanadium.
+2 +3.
Okay. As one easy way before this, one easy way to predict the likely oxidation state was, now you won't have a data booklet with you, okay? But previously, one easy way to predict the likely oxidation states was that you could just look at the redox table, and over here you can figure out that vanadium is +2, it's +3. It's also I think over here it's +4 as well. In VO2 +1, it's +3. Okay, so you can figure out the oxidation states, the common ones, using this table over here. But now it's not there. Okay, so now you would have to memorize these. Okay, so memorize the common ones. I'll say.
So the फिर हमारे पास जो electrolysis में questions आते हैं कि what will be the product at cathode and anode, तो वो तो फिर ये data booklet पे dependent है.
नहीं, data booklet would be given in the question if it's required. ठीक है,
I mean,
but
और हमारे पास products of electrode, cathode and node, I mean, we have to decide that according to these values, right?
but that would be given in the question now. I'm just saying that in this question, they didn't tell you to look at the data booklet, right? So basically you don't, I mean, you have to remember this. So vanadium is going to be, I mean, hopefully this is vanadium. It's going to be +2 or +3 or +4. They were asking for any one of them. So you're going to predict the likely oxidation state. Suggest why transition elements often show variable oxidation states in their compounds, but typical S-block elements such as calcium do not. So the reason is you got electrons in the 3D and you got electrons in the 4s as well. So it's kind of easy to remove electrons from the 4s, but the energy difference between the 3D and the 4s is not very high. So you've got a 3D subshell where you can remove electrons as well. So there's very little energy gap. That's what you're going to write. I'll just quickly open the MS as well. That is the user term. 1 second. Okay, easily accessible 3D orbitals are present. This one
सर
second.
जो इलेक्ट्रोलिसिस में लेबल डायग्राम्स ड्रॉ करते हैं हम उसमें जो हम लोगों ने आयंस वगैरह लिए हैं तो उनकी इलेक्ट्रोड पोटेंशियल होना पता जरूरी है या फिर उसके बगैर भी हो जाएगा?
Yeah, I think you should use that. लेकिन that's why you have a data booklet, right?
लेकिन
So-
आई अटेम्प्टेड अ क्वेश्चन जिसमें वो इक्वेशंस जो थी उन्होंने दी हुई थी लेकिन वो डेटा बुकलेट में थी नहीं इक्वेशंस.
कौन सा वाला? मुझे दिखा देना. There's some questions. I mean, it's in electrolysis. It sometimes is easier to just use the O levels concept. Like if it's a 1 mark question, they're just asking for the product. Using the data booklet, like for example, if they use NaCl concentrated, they ask you what is the product at anode. That's obviously going to be chlorine. So you can directly answer that if it's a 1 mark question. You can send me the question कि कौन सा वाला है, ठीक है?
फरवरी मार्च 19 का है.
तो मैं end में रख लेता हूँ, ठीक है?
ठीक है.
So okay, they're using the same term, that 4s and 3d, they have very similar energy, so which is why it's easy to remove electrons from the 3d as well, which is why they have variable oxidation state. In calcium, that's not possible. Why? In calcium, you've got I mean, if you write the electronic configuration of calcium, it's 3p6 and then there is 4s2. The 3d is completely empty. I mean, there is no 3d. So the energy gap is a lot. You remove the first 2 electrons, removing the next electron kind of becomes very hard. Many enzymes contain defined with the 8, so that's no longer in your course, so we're going to ignore that. Okay, let's move to the next one, which is this question. Okay, I think we did this once. I'm gonna just quickly do this again. That's they're saying MnO2 catalyzes the decomposition of hydrogen peroxide as shown. So MnO2 is your catalyst. Remember, the catalyst is reformed. The mechanism involves the formation of the intermediate species Mn2+. So the first step involves in the first step. So we know that the MnO2 turns into Mn2+. So I'm going to refer to the data booklet. I mean, they've already told us that that's what is happening in the first step. So I'm going to go for the equation where MnO2 is turning into Mn2+, which is this one over here. Okay, they've already told me that MnO2 turns into Mn2+, and that's 1.23. So MnO2 turns into Mn2+, there's 4H plus 1, and I think 2H2O. And the E naught was 1.23 volts, right? And 2 electrons as well. This one. Plus 2 electrons. So we know this is happening. And this is gaining electrons, right? I mean, they've told us this is the reaction, right? It's all written over here. So they've told us this is the reaction. And I've written the equation using the data booklet. Now, who gains electrons? The one that has the higher potential or the lower potential?
The one with the high potential.
Higher.
So that's going to be higher. So that's going to be your higher potential, right? So who is MnO2 reacting with? The MnO2 must be reacting with H2O2, right?
Right, yeah.
And so if MnO2 is the one that's gaining electrons, according to their first step, they've said that it's gaining electrons. They've told us what the equation is. Then H2O2 must be the one that loses electrons, right? So I'm going to go and look for an equation where H2O2 loses electrons. So H2O2 must be on the right side. It must be the lower potential for it to lose electrons. So we're going to find H2O2 equation, and I found one, which is this one. Okay, that's this one, H2O2 losing electrons, that's 0.68. That is the lower potential. So going back to the question, I've got H2O2. The E naught was 0.68 volts. Or kya tha ke there was O2 plus 2H plus 1 plus 2 electrons. So I've figured that out. And I'm going to try and find out the overall reaction, which is going to be H2O2 losing electrons. That is the lower potential. So this works. The first step works, and we can write the overall equation, which is going to be you just add up the reactant. It's going to be MnO2 in the reactant side, 4H plus 1. In my product side, I'm going to have Mn2 plus. And in the other product side, I'm going to have, there were other reactants as well. There's O2.
Sir,
हाँ.
आपने बताया था कि Mn का कोई specific equation use कर लिया करें ताकि लंबा ना जाए. Which
नहीं,
equation was that?
नहीं, वो मैं बता देता. That was something else. That was कि if they tell you to do a reaction of MnO4 acidified, right?
जी.
Let's say they told you to do a reaction with MnO4 acidified. In that case, I told you that MnO4 acidified has a very high potential. It's always going to gain electrons. So you got two equations of MnO4 which are acidified, right? And it is the higher potential. It's a higher potential compared to pretty much everything else in the periodic table. So MnO4 minus 1 is going to gain electrons, whatever the other substance is. It's going to be the higher potential. So the higher one is 1.67. So according to the, basic idea, this is the equation that you're going to select, right? But I told you to not select that one. I told you to go for this one. Because there's going to be a chain reaction. And eventually this MnO2 will react further to form Mn2 plus. So instead of actually going through the whole hassle of doing the question twice and repeating it and then turning the MnO2 further into Mn2 plus, you could just straight away go for this equation. And that will pretty much so. Okay.
So,
again, coming back to this question, I've got the reactant 4H plus 1 MnO2. The other reactant is O2 plus 2H plus 1. Yeah, no, am I doing this right? I mean, it's wrong. It's
2H plus.
No, it's I wrote the equation. 1 second. I wrote this the other way around. This is a loss of electrons happening. I already wrote it in reverse. This equation, H2O2 equation, I already wrote it in the reverse direction, so I don't have to sort of reverse it again. Anyway, so that's your loss of electrons, so that's going to be H2O2, right? That's my reactant, and my product is going to be O2 plus 2H plus 1 plus 2H2O. Okay, is this clear? That's your first reaction. MnO2 turning into Mn2 plus, that's a gain of electrons. Who gains electrons? The one that has a higher potential. And if this is gaining electrons, the other one would be losing electrons. So if that is losing electrons, so I found the equation where H2O2 is losing electrons, and that must be the lower potential. I added up the reactants, I added up the products, and this is my equation for step number 1. Okay, is this clear?
Ji, sir.
Yes.
And you can write the E naught as well for this, and you have to answer all of this. You can make sure you read the question properly. State and use relevant electrode potentials. So quote the electrode potentials, and to construct two equations to show how this two equations. What's the step number 2? Now step number 2 is the reverse is going to happen. The Mn2 plus should convert back into MnO2. So you need the reverse reaction now. So I want, if I go back to the data booklet, and if I revisit my my MnO2 equation, I said now a catalyst has to be reformed. So at the start, I had MnO2 and it turned into Mn2 plus. So in step number 2, the reverse is going to happen. It should lose electrons and turn back into MnO2 because the catalyst has to be reformed. So who loses electrons? The one that has a lower E naught, right?
Mm.
So that, and now I'm trying to predict the second reaction. So it must be the one that should be losing electrons, right? So, clear in the Saroko, is this clear to everyone that if in the first step, the catalyst gains electrons, turns into Mn2 plus in the next step, which they didn't give us any information about the next step. But the logical step would be that the Mn2 plus should convert back into Mn2 plus.
Mm-hmm.
So let's focus on this one. So this is losing electrons. So whoever the other thing is, there must be something that would be gaining electrons. Now the only other thing we have is H2O2. There's only two reactants. So the other thing is H2O2. So I'm going to look for H2O2 gaining electrons, which I don't see anywhere. Can't be H2O2. So I found one. So H2O2 is gaining electrons. Just a second. So that's my H2O2 equation gaining electrons. And that potential is 1.77. That is obviously it is the high E naught, and high E naught is supposed to gain electrons. So that makes sense. So this is what I did. I wanted the Mn2 plus to turn back into MnO2. I wanted H2O2, and there was only one other thing in the whole reaction. So H2O2 would be gaining electrons. So that's going to be my high E naught. And that I'm going to just add up the two equations to make the reaction. The electrons are already balanced. So the reactant over here is Mn2 plus 2H2O. The reactant over here is H2O2 plus 2H plus 1.
Sir, which equation did we use against this MnO2?
Recap. So the product is going to be MnO2 and 4H plus 1, and the other product is going to be 2H2O in the bottom equation. That's going to be my product. And you can calculate the E naught cell. It makes sense. That's the lower potential. This is the higher potential. So just a quick recap on the whole question. You can remember this is a slightly difficult question. They told us that Mn2 plus is formed. So MnO2 turns into Mn2 plus. So the whole data booklet had only one equation where you had MnO2 turning into Mn2 plus. Is this clear? So I said, now in the first step, this reaction happened in the opposite direction because they told us that MnO2 gained electrons and turned into Mn2 plus. So MnO2 turning into Mn2 plus, the reaction would be gaining electrons. It's the same equation, 1.23 volts. But right now it's gaining electrons. So in the first step, it's going to be the higher E naught. Okay? So the other thing, H2O2 must be the one that would be losing electrons, right? So it must be the lower E naught. So in that case, but if I do all of that on the data booklet, in the first equation, MnO2 was gaining electrons. So it must have been the high E naught. And H2O2 was the one that was losing electrons. So it was this one. It was losing electrons, and it was the lower E naught. Is that clear?
Yeah.
So like the next logical step was that since they told us that the MnO2 is the catalyst, so the second step would have been the MnO2 has turned into Mn2 plus, but in the second step, the Mn2 plus should convert back into MnO2 because the catalyst has to remain unchanged. So I'm going to select the same equation, but this time it should be losing electrons. So when I did the second step, which is this one, in that step, I wanted to convert the Mn2 plus back into MnO2. And who loses electrons? The one that has the lower E naught. So in that case, this was the lower E naught. And therefore, the H2O2 must be gaining electrons. So I found an equation for H2O2 where it's gaining electrons, which was this one, and it must be the higher E naught. So that was a separate reaction. Okay, bro, is this clear?
Yeah.
So we found out two reactions in this way, and you can make up. I wrote the equation number 2 over here. That's my equation number 2. And then we have this question, which is, you clear, Sarogo? Is this clear?
Yes.
जी सर.
ठीक है, एक सेकंड ना. So next one, the equation for the decomposition of hydrogen peroxide without a catalyst is shown. So under certain conditions, this reaction is found to be first order with respect to hydrogen peroxide. Okay. Under certain conditions, so first order, right? With the rate constant of the rate constant is also given. That's 2 into 10⁻⁶. and calculate the initial rate of decomposition of 0.75 mole per dm cube H2O2. So that's easy. It's there's only one reactant, right? So the rate is only dependent on this particular reactant, which is H2O2. And the power is 1. The order is given, it's first order, right? So since it's first order, they gave us the value of K, that's 2 times 10 power minus 6. And they gave us the H2O2 concentration as well. That's also provided. So that's 0.75. That's it. So find out what is the value that you're getting.
(1.5 10 to the power minus 6).
So 1.5 times 10 power minus 6. Then a 4-step mechanism is suggested for the reaction between hydrogen peroxide and iodide ions in an acidic solution. What is meant by the rate determining step? That's the slow step in the reaction. In the reaction mechanism. Okay, that's your rate determining step. These are definitions. Reconfirm bhi kar lein ki a slow step in overall reaction. Okay, that's it. Now use this mechanism to construct a balanced equation for this reaction. The overall reaction, what do? You just add up all the things. You add step 1 to step 2 and step 3, step 4, all of them get added. So the what is going to get cancelled out? The IO minus 1 is going to get cancelled out. The HIO is going to get cancelled out. What else? OH gets cancelled out. So basically the overall reaction is you got left hand side. You got H2. It's not getting cancelled out. Left side you've got H2O2 plus I minus 1 plus 2H plus 2I minus 1 actually. Plus 2H plus 1, right? And the right side has 2H2O plus I2, I think. Now, deduce the order with respect to each of the following. And he told us that step 1 is the rate determining step. So if step 1 is the slow step, this is the rate determining step. They've already told you that. So what is the order? What is the rate dependent on?
H2O2 and iodide.
So that's first order with respect to both, right? And it's going to be 0 order with respect to H plus 1. Okay. I'll just further do this for revision that what if step 3, let's say, is the slow step? So how would you determine the order? The rate would be dependent on what? These two? So rate would be dependent on I minus 1 concentration. I mean, this is not part of the question. I'm just assuming, let's assume that step 3 is the slowest step. So it would be dependent on I minus 1 and it would be dependent on HIO concentration, right?
Mm-hmm.
And then what you're going to do, that HIO itself is dependent on these two, right? So when I say that rate depends on HIO, it actually indirectly depends on H plus 1 and IO minus 1, right? Is that clear?
Yes.
So my rate equation changes into this. But then I see IO minus 1. I figure out that IO minus 1 itself is dependent on these two things. So I'm going to remove IO minus 1 and I'm going to replace it with IO minus 1. When I say rate depends on IO minus 1, it indirectly depends on
negative H2O2.
H2O2. Okay, so that way, the overall rate equation would be, I minus 1 would become squared. It would become order 2. H plus 1 is only coming once. And H2O2 is also coming once. Okay, so remember this as well. That if any of the other steps are the slow step, make sure you trace the intermediates and figure out what are they dependent on. Achha, so
how do we calculate wo rate determining step isme?
They told us the rate determining step.
If we had to.
If we had to, if somebody had told you the order, let's say if somebody told you that the order, like you do know, okay, you can figure out the order experimentally, right?
जी.
By looking at the half-lives or by looking at the table, okay, you can do several experiments and figure out whether the order is 0 or 1 or 2, right? So let's assume that you figured out the order, it's 1, 1 and 0. So you're going to do trial and error. Let's assume that the first step is the slow step. If you use the first step as the slow step, the order would come out to be 1, 1, 0, right? What if they told you that the rate, the order with respect to each reactant was 2, 1, 1, right? So you're going to get 2, 1, 1 if you choose step 3 as the slow step. So bari bari karke na, what you'll do is you'll select one of them as the slow step and see does the order match with the orders that you're getting. Is that clear?
Yeah. ठीक.
It's a Pisla question. This is about what is meant by the buffer solution. So it's a solution that resists a change in pH when a small amount of acid or alkali is added. Ammonium ions, he's talking about K, so it's acting as an acid. It's going to be NH4 plus 1. It will ionize, it will produce NH3, and it will produce H plus 1. Remember, this is your standard acid dissociation equation, something that will produce H plus 1 and some other thing. So what is the expression? Products over reactants, it's going to be NH3 concentration into H plus concentration divided by the NH4 plus 1 concentration. And again, write two equations to show how ammonium ions act as buffers, like ammonium and NH3. If I add H plus 1 ions, which one will react? This is the acid.
NH3.
Okay, and that's your conjugate base. So the NH3 will accept the H plus 1 and it will form NH4 plus 1.
So
and if I add,
which one is the conjugate?
Ye conjugate base hai na? But this is the, I mean, this is the acid.
The conjugate base.
And that's your conjugate base. Okay, that's your conjugate base. A buffer is formed when you have both of them in the solution. So OH ions, who's going to neutralize the OH ion? It's going to be
NH4.
Okay, it's going to be NH4 plus. So water is going to be formed and NH3, right? I said, so next question is about buffer. Remember
हाइड्रोजन डायरेक्ट हाइड्रोजन ऐड नहीं होगा OH के साथ और H2O फॉर्म करें
तो वो हाँ वो हो गया ना फॉर्म न्यूट्रलाइज हुआ है ना the OH ion got neutralized the NH4 plus 1
do we have to write NH4 के नहीं हाइड्रोजन है
you have to write NH4 plus 1 ठीक है that अगर if you just write hydrogen that would not be a complete reaction. I mean you're just writing a partial reaction. Okay, so it's NH4 plus 1, that's the one that's producing H plus 1. So next one is, okay, I've got a numerical value of K for NH4 plus 1 is 5 into 10 to the minus 10. A buffer solution was prepared by adding ammonia with, I said, this is the same question. Firstly, there's going to be a reaction. Initially, it's not a buffer. Okay? Because initially, you've got ammonia and you've got HCl. Now, ammonia and HCl are not going to form a buffer. Who's going to form a buffer? Ammonium ions and NH3. The first thing that's going to happen is there's going to be a reaction. NH3 is going to react with HCl. And when it reacts with HCl, it's going to form NH4Cl plus H2O. Okay. Achha, how many moles of NH3 do you have? You've got 0.8 mole per dm cube of 0.8 dm cube or 0.25 mole per dm cube. So how many moles is this?
0.8 into 0.25
divided by 1000. Kya banta? Nee, sorry, not divided by 1000 because it's T. So what?
0.2. एक second, sir.
How we log 0.
हाँ जी 0.2.
Achha, so this is 0.2 moles, right? Achha, how many moles of HCl do you have? That's 0.2 into 0.2, so क्या होगा 0.04?
Yes.
So this is 0.04 moles, right? So this one is 0.04 moles. Now, which one is in excess? HCl is going to completely react because it's a limiting reagent. Okay, you added too little of it. 0.04 is going to react with 0.04 moles. So how much is left? 0.16 moles would be left, right?
Yes, sir.
Okay, so I'm just going to repeat. Okay, 0.04 will react with just 0.04. 1:1 may they react. So 0.04 will react with 0.04 only. And it will produce 0.04 moles of NH4Cl and 0.04 moles of
H2O.
H2O. Okay, so you're going to get this. So now you have a buffer because you have NH4 plus 1 and you also have NH3 in the solution. So
Yes.
now it's a buffer. Now it's a buffer. So you'll just use the same Ka expression. You're given the Ka value as well. That's 5.6 times 10 raised to minus 10. So use that. The NH3 concentration is what? It's 0.16. And the NH4 plus 1 concentration is 0.04. You don't need to find concentration because we'll divide by volume. If you numerator over denominator, it's going to get cancelled out. So no need to do that. And you'll find H plus 1. So it's concentration. So
Sorry,
find
sir.
out
What will get cancelled out?
किसका?
What will get cancelled out? आप क्या कह रहे थे?
नहीं वो मैं कह रहा था कि I'm using moles, right? कि यहाँ पे the term that you're going to use is the concentration of NH3 divided by the concentration. ठीक है? तो मैंने कहा था divide by volume part, you don't have to find the concentration. You don't have to divide by volume because it's numerator over denominator, so it's going to get cancelled out anyway. So no point doing that.
Okay.
You can directly put in moles. हाँ.
जी दूसरा यही बफर वाला क्वेश्चन मैं सॉल्व कर रहा था लेकिन उसमें थोड़ा मसला आ रहा था उसमें कंसंट्रेशन ऑफ ये सॉल्ट गिवन नहीं था मैं आपको डिक्टेट करूं छोटा सा क्वेश्चन
भेज दो अगर वो कौन सा पेपर
विंटर 1943 क्वेश्चन 5
चलो अभी बफर कनेक्ट खोल लेते हैं एक सेकंड 9701 विंटर 1943 अच्छा कौन सा इस पे
क्वेश्चन 5 B2
अच्छा सर वैसे पिछले वाले में जब H प्लस निकला आता फिर माइनस लॉग H प्लस करते तो pH निकला आता ना
हाँ वो H प्लस निकला माइनस लॉग लेना दैट्स pH ठीक है वो निकला बता दो ये वाला दिस वन
ये B2 ये वाला
ठीक है it's a very similar question the K is given and they're talking about this acid HOBr ठीक है now we don't know what HOBr is but again it's the same equation okay I've got HOBr so what does the acid do they've told us that it's an acid right it releases an H plus 1 ion so what is left it's going to be an OBr minus 1 ion right clear what is the K expression it's going to be the same thing it's going to be H plus 1
OBr minus
ठीक है that's the conjugate base concentration divided by the
or HOBr
the acid ठीक है तो बस ये अच्छा the question is exactly the same कि they're adding KOH now KOH is not going to form a buffer is going to be formed when you mix the conjugate base with the weak acid so KOH has nothing to do with that so initially this is not a buffer ठीक है it's got KOH that's being mixed with HOBr so yeah so there's going to be a reaction acid base reaction what is the salt that's going to be produced KOBr would be produced plus water ठीक है well is this clear okay, that's how salts are produced that the H in the acid gets replaced
yes
ठीक है अच्छा that's going to be your salt how many moles do you have you've got 5 into 0.2 divided by 1000
1 into 10 to the minus 3
so this is 1 into 10 to the minus 3 moles and HOBr moles that's
4 into 10 is to the minus
4 into 10 to the minus 3
Okay, so which one is in excess? 1 into 10 to the power minus 3 is going to completely react, right?
Yeah.
And it's going to react with 1 into 10 to the power minus 3. So 3 into 10 to the power minus 3 would be left in the solution. And 1 into 10 to the power minus 3 will react with 1 into 10 to the power minus 3 to produce 1 into 10 to the power minus 3 of KOBr.
KOBr.
So basically, the amount of OBr minus 1 ions would be coming from the salt, which is KOBr. That's so this would be 1 into 10 to the power minus 3. And HOBr would be 3 into 10 to the power minus 3. So ye jo hai na, this is 3 into 10 to the power minus 3. So just plug in these values. This goes over here. This one goes over here. The K value is also given, that goes over here, and you'll find H plus 1.
Sir, ये जो आप use कर, this is the same thing as pK plus log of salt or acid. यही है?
हाँ, बस इसका अगर log ले लो, that's going to be P minus log. Sorry, it's going to be PK. It's the same. It's the same expression.
सर लेकिन ये जो आपने लगाया है जो वर्किंग की है तो दूसरे पार्ट के लिए ना, पहले पार्ट के लिए हमें 0.2 मोल पर डीएम क्यूब गिवन है, तो उसको किस तरह सॉल्व करेंगे? B1
अच्छा, पहला part, ठीक है. Remember, I told you that there were going to be 2 questions, right? I told you the expression would be the same.
Yes,
but in a buffer, this ion, the only difference is okay, this formula is going to be used in 2 ways. One is a buffer. In a buffer, the concentration of H plus 1 and OBr minus 1 is not going to be the same. Because the ion jo hai na, you're adding extra of this ion, okay, from the salt. So isliye, but if you just have a weak acid, like in part 1, you just have a weak acid. So the same expression, it's going to be the same expression. It's going to be K is equal to H plus 1 into OBr minus 1 divided by HOBr. So now if it's not a buffer, तो
ऊपर स्क्वायर हो जाएगा ना?
हाँ, तो ये वाला ion and this ion, they would have equal concentration because all these 2 ions are being produced when the acid dissociates, right? This is not coming from any other place. So if this dissociates,
तो HBr को एक ही साइड पे जाके फिर उसका अंडर रूट ले लें और फिर आपका H plus वैल्यू निकलेगी.
तो उसको, तो आपका जो expression है, that's going to change to H plus 1 square divided by the acid concentration.
ठीक है सर.
मैं कह रहा हूँ, if only weak acid is present, not a buffer, so your formula changes to this one because these 2 will have equal concentration. ठीक है? Clear? तो उसने कहा था find 0.2 mole per dm cube. So you know what the K is. The acid concentration is 0.2 mole per dm cube, so you can obviously figure out H plus 1 concentration. So again, I'll just repeat. It's the same formula, except there are 2 ways of using this particular formula, which is one is that you have a buffer. So in the buffer, the OBr minus 1, the conjugate base, whatever the acid is, the conjugate base would be added from somewhere else as well. So the concentration of these 2 ions will not be exactly the same. So you're going to use the full expression. The other one is if you just have a weak acid, it's going to be the same expression, but now this ion and this ion will have equal concentration. And in that case, it's going to become H plus 1 squared. So you'll use this formula if it's just a weak acid and not a buffer. So वापस उस पे चले जाते हैं कि कहाँ है हमारा पेपर, इस पे आगे थे. We're done with this, ठीक है? Did anyone? हाँ.
Yes, sir. Which is a paper, sir? This is a paper 2019.
ये कौन सा ये वाला?
This one, sir. Yes, yes.
This is winter 1943. Achha, coming back to this, I think we're done with this. Just find minus log. Did we finish the question? We did. Achha, let's do the previous one, which is about KSP. So finding the units, what is KSP? That you dissolve a solid salt and it turns aqueous. It's Ag2CO3. That's a solid. It's going to ionize. It's going to produce 2 silver ions, aqueous, and 1 carbonate ion, which is going to be aqueous.
So what is solid?
Because solid is 1, its concentration is taken as 1. So product over reactants, the reactant is a solid. So it's going to be silver ion squared and carbonate ion would be power 1. Units would be concentration squared into concentration. So that's going to be mole 3 dm minus 9. That's going to be my unit. We have to find the equilibrium concentration of silver ions at 25. So at 25, we're going to find silver ions. So what are we going to do? Okay, I'm going to assume that X mole per dm cube of silver carbonate dissolves. And if it dissolves, it's going to produce 2x mole per dm cube of silver ions. And it will produce X mole per dm cube of carbonate ions. So the Ksp value is already given. So I'm going to use this expression. The Ksp value is given as 6.3 into 10 to the minus 12. I just don't know what the concentration of silver ions and carbonate ions is. But I've taken that as X. Okay, whatever the concentration of carbonate is, the concentration of silver ions is going to be double that. So if I put that in the expression, it's going to be 2x squared into X. Okay, silver ion concentration squared. And I'm going to find what X is. Kya aa raha hai hamara X? What is X?
.16 10 to the power minus 4.
Okay, so we're getting 1.16 into 10 to the power minus 4, but that's not the answer. It should be into 2 because they were looking for silver ion concentration and we took it as 2x, right? Is that clear?
Yes.
ये क्या question है? So solid silver carbonate is stirred at 25 with this silver nitrate until no more Ag2CO3 dissolves. Calculate the concentration of carbonate ions in this solution. So, क्या हो रहा है यहाँ पे? Solid silver 2 carbonate is stirred at 25 with 0.5 mole per dm cube of silver nitrate. So I've got Ag2CO3 and I've got AgNO3. And until no more Ag2CO3 dissolves. So calculate the concentration. This question is about the common ion effect. So it's basically the same Ag2CO3. That's you have the same Ag2CO3. This was the equilibrium that you had 2 silver ions and you had a carbonate ion, right? But now the problem is that when I mix silver carbonate in silver nitrate, the solubility would decrease because the solution already has, like if you're mixing silver carbonate and silver ions, right? So the concentration of silver ions is really high because that's a common ion. It's coming from this, it's also coming from the other side as well. The solution already has silver ions. Is the point clear? So what happens if the solution already has silver ions? Where would the equilibrium shift?
Backwards.
Left hand.
Towards the left. So the solubility of silver carbonate is going to decrease. So silver carbonate is going to be less soluble in silver nitrate because of the common ion. Because there's already too many silver ions in the solution. Pehle se hi, theek hai? Silver ions are already there. So the concentration is high, so the equilibrium would shift to the left. So what is the concentration of silver ions now? That's given, that's 0.05 mole per dm cube, right? So that is already, I mean, the solution already has silver ions, so it's 0.05 mole per dm cube. So we're going to try and find out what the concentration of carbonate ions is now. So I'm going to take that as X. So the only difference is, in the previous case, if the concentration of carbonate ion was X, the concentration of silver ions was 2X, right? But now there's no relationship because the silver ions are already part of the solution. So if the concentration of carbonate ions is X, the concentration of silver ions is already given, that's 0.05 mole per dm cube. So we're going to use the same Ksp expression, exactly the same Ksp expression. What was that Ksp expression? That was silver ion concentration squared into carbonate ion concentration. So 0.05 squared into the carbonate ion concentration, which we don't know. And the value of Ksp, we already know that. That is 6.3 times 10 power minus 12. So I'm going to use that value. So tell me, what is the carbonate ion concentration? Minus 12, sorry.
सर
हाँ.
उन्होंने जो concentration बताई हुई है it's for AgNO3. आप वो Ag carbonate के लिए क्यों यूज कर रहे हैं?
मैं इसलिए यूज कर रहा हूँ कि let's assume you've got silver nitrate, right, in the solution. Okay, let's assume you've got silver nitrate. And that's 0.05 mole per dm cube. So he's talking about the aqueous solution that has already dissolved. So the amount of silver ions would be 0.05 mole per dm cube. यहाँ तक तो clear है ना कि if you just have silver nitrate, it's going to be 0.05 mole per dm cube. That's going to be the concentration of silver ions. Now, if I add solid Ag2CO3 to it, right? But what will happen to the concentration of silver ions? It's going to increase, right? Because there's going to be some silver ions coming from here as well, right?
Yes, yes.
ये question है ना कि like if you add silver ions, silver carbonate to it, the concentration of silver ions should increase. अच्छा, now the question is, पहले वाले को देखो, the previous one, when there was no silver nitrate, what was the concentration of silver ions in the solution? 1.16.
1.16
into 10 to minus into 2 chalo, ठीक है. Try adding that to 0.05. So firstly, you're getting this when there was no silver nitrate, but we just discussed okay, what will happen to the solubility of silver carbonate? It's going to decrease further, right?
Yes.
तो मतलब जो पहले थी, the previous value, it's not going to be even close to that. Maybe let's give it a hypothetical value, because now there's a lot of silver ions, so the solubility of silver carbonate decreases further. I'll just give it a hypothetical value. Let's say it's 2 into 10 to the minus 6 now, mole per dm cube, because it has decreased. Okay, we did talk about it decreasing, right? Is that clear?
Sir,
तो
आप आगे समझाएं, मैं पूछती हूँ.
अच्छा, so the point is that the solution has 0.05 mole per dm cube of silver ions. The amount of silver ions that will now be produced by silver carbonate would be very less, and that would be negligible. Like, I don't need to add that. So it's approximately 0.05 mole per dm. There's no point adding these few silver ions that are now going to be produced from the silver carbonate, because now the amount of silver ions from silver carbonate would be produced, there would be very few. Okay, is this point clear?
Yes, sir.
Yes, sir.
सर ये 4x क्यूब किस तरह है?
वो तुम कहानी और पीछे रह गया. ये बच्चों पहले इस पे तो रुको ना. हाँ
सर, मुझे वो नहीं समझ आया क्या ऊपर जो concentration ली है, why can't we use that concentration नीचे हम लोग NO3 की, हाँ जो हम लोगों ने ऊपर निकाली थी, because वो वाली हम concentration अंदर add कर रहे हैं ना, and फिर उसके हिसाब से we have to take our carbonate की.
एक सेकंड, स्पेस और ड्राइंग की, just 1 second. इसी तरीके. अच्छा, क्विकली कि ये सारा अगर यहाँ पे if I draw this over here, you've got 0.05 mole per dm cube silver nitrate, right? So ये clear है, the solution already has silver ions, and the amount of silver ions that it has is 0.05 mole per dm cube, right?
Yes.
And then in the same solution, we are adding, in the same solution, we are adding solid silver carbonate, right?
उसकी concentration is अलग.
And we learned in the previous step that if in a normal solution, the amount of silver ions that silver carbonate would produce, that's going to be 1.16 into 10 to the minus 4 into 2, okay? वो जो भी number है, let's call that 2 into 10 to the minus 4, right? So we learned, I just rounded off, okay, that in a normal solution, if there was no silver ions in a normal solution, it's going to produce 2 into 10 to the minus 4 mole per dm cube of silver ions, right? So what are your
only if there were already no silver ions in the other solution.
हाँ अगर solution में सिर्फ water होता है, मैंने यहाँ पे तो problem है कि there's already silver ions present, ठीक है? So we also learned that the solubility would decrease further. Is that clear? The solubility would decrease further because silver carbonate is not going to dissolve if the concentration of silver ions is already very high. Is that clear as well?
Yeah.
So the concentration might decrease further. Like its solubility would decrease further, and let's say it becomes 2 into 10 to the minus 6. Okay. So my only point is, most of the ions in the solution are coming from the 0.05 mole per dm cube of silver nitrate that's already dissolved. The amount of silver ions that will now be coming from silver carbonate would be very few, that you can ignore them. It's pointless to add this to this. Okay, that's negligible, right? I'm just giving you the idea. So we're going to assume
दोनों की concentration कम नहीं होगी?
किसकी? नहीं, उसकी कम नहीं होगी, वो तो dissolve हो चुका है, and that is very soluble. ठीक है, nitrates are very soluble, so it would probably not. I mean, all nitrates are very soluble, so they're not going to form a precipitate that easily.
Okay.
So, and that is already dissolved, so that's already part of the solution. It's just that further silver ions from silver carbonate, very few of them will get dissolved. So, but the point is, so the point is, this is what you're going to do. Keep things simple in a common ion question. You're going to assume that most of the silver ions are actually already part of the solution. Okay? Any further silver ions that are going to come when you dissolve the salt, they would be very few. So the approximation would be you're going to take it as 0.05 mole per dm cube. Is that point clear?
ठीक है सर.
जी.
और बाकी रह गया carbonate ions. The carbonate ions are the ones that are coming when this thing dissolves, because the carbonate ions are not the common ion. They're not present initially, so the carbonate ions are coming from there. So its concentration is unknown. So you're going to use the same KSP expression, and you're going to find. So you're going to use. You're going to use the same KSP expression, and you're going to use the same KSP value as well. What is the KSP value? That's
ये जो मोल्स होते हैं वो negligible नहीं होते, तो फिर तो हम लोग को ऐड करनी पड़ती ना दोनों की concentrations.
हाँ, लेकिन negligible है. Well, it's क्योंकि just remember the common ion. If the solution already contains too many of the common ions, the further common ions that are going to be dissolved, they would be very few, and that's going to be negligible. You're going to take that as negligible. Okay? So your approximation would be that the silver ions are already there, and it's 0.05 mole per dm cube, and it's not changing. Okay? So you're just going to measure carbonate ions. So it's going to be 10 power minus 12. That's going to be, what was KSP? That was silver ion concentration squared, 0.05 squared into X. And you're going to find the value of X. Is that clear?
Yes, sir. सर बस वो 4x क्यूब वाली मुझे बात नहीं समझ आई थी.
अच्छा वो ये कि क्या फॉर्मूला था? It's equivalent constant, right? So silver ion squared into carbonate ion power 1, right? लेकिन मैंने assume किया था कि the concentration of carbonate ion is X. So the concentration of silver ion would be 2x, right? ये clear?
Yes, sir.
तो
और क्योंकि 80 के 2 मोल्स है तो वो 2x स्क्वायर होगा into x.
हाँ, बस वो है, ठीक है.
सही सर. तो ये 2x क्यूब नहीं बनता फिर?
कौन सा?
ये फिर 2x क्यूब ना बनता?
2x स्क्वायर होगा, क्या होगा? What is 2 square?
अच्छा 4x स्क्वायर.
2 का भी स्क्वायर हो गया ना?
हाँ, ठीक है. वो कर लो ना, वो मैथ है, वो तो आप खुद ही सॉल्व करो. 4x क्यूब हो जाएगा. अच्छा, बस ये क्वेश्चन जल्दी से खत्म करें. Cell is set up measuring to measure the electrode potential of silver ion silver and using the saturated Ag2CO3 with a standard hydrogen electrode. So use the data booklet and your answer to A2 and the Nernst equation to calculate the electrode potential. So silver Nernst equation aa gaya. It's a question on Nernst equation. So you have to find. Acha, E naught is 0.8 volts. This is from the data booklet, right? Acha, what is the Nernst equation? The Nernst equation is that the new potential is the old potential plus 0.059
divided by Z.
You get number of electrons log of oxidized species over reduced species. Oxidized, which one is the oxidized species? Basically, it's
The
left side over
Ag
left
plus,
side over.
Ag plus.
So left side over right side. So it's Ag plus concentration over 1. Okay, Ag is a solid. Okay, so solid is going to have a concentration of 1, a constant concentration. So you're not going to write Ag plus 1 over Ag. You'll just write 1. And Z is the number of electrons. That's also 1. So you have to use that. And he's saying use the answer to. We did calculate the silver ion concentration in Ag2CO3 aqueous, which was 2 into 1.16 into 10 to the minus 4. So we'll just plug that in. It's going to be 0.8 plus 0.059, and that's going to be divided by 1 and log of 1. Ag plus 1 concentration. That's 1.16 into whatever that was. Minus 4 into 2, right? Over 1. So just solve this and you'll find the value. Okay? Is that clear?
Yes, sir.
सर आखिर में log के बाद ऑक्सीडाइज जब रिड्यूस लिया आपने
हाँ,
तो वो फिर ओवर 1 क्यों है क्योंकि 1 सॉलिड की वो कंसंट्रेशन है
हाँ, क्योंकि it's this concentration over this concentration, right?
सही है आगे
So
वाली
solid,
ऑक्सीडाइज है
हाँ, remember solid is going to be taken as 1.
सो फिर 1 ऊपर ना आता क्योंकि it's oxidized over reduced
नहीं, oxidize ये वाला है. Oxidize is the one that's formed after oxidation. Reduced is formed after reduction. So simple oxidize or reduce की बजाय ना the easy way is left over right, left side over right side.
ओके सर
ठीक है. अच्छा, so entropy change, you can find out that's easy. How do you find entropy change? Products over?
Minus reactants.
That's a minus reactants. So in this case, it's going to be product is Ag plus 1 aqueous 72.7. The other product is 56.5, and there's one of them, one of each. And your reactant is 96.2. Let's try and find that. And explain with the aid of a calculation why AgCl is insoluble in water at 25. And you should use
मतलब less feasible ना
less feasible, right? And
yes.
there are many reasons for that. I mean, you don't need to find entropy change. You can also explain that using enthalpy change. It's endothermic, right?
Yes, sir.
But you won't be explaining it using delta S. I mean, it's not a question about feasibility or sorry, with an aid of a calculation. So I think he's talking about feasibility, that delta, because he gave us delta H. You're right. Okay. The general answer would be it's endothermic, so it's obviously it needs energy. So delta G is equal to delta H minus T delta S. So what are you going to calculate? You're going to calculate delta G. What is the predicted value? Okay, what should delta G come out to if it's unfeasible?
Positive, more
positive.
Positive.
Yeah.
And just be careful make sure the units are right. Delta S is in joules and delta H is in kilojoules. To just make sure that the units are the same. For delta G, it's usually kilojoules. So divide the delta S by 1000. But for delta G would come out to be a positive value, and then you're going to say it's unfeasible. ठीक है? हाँ जी ये
जो डेल्टा H माइनस T डेल्टा S है इसके अंदर T और डेल्टा S को पहले मल्टीप्लाई कर लें और फिर इसको माइनस कर दें डेल्टा S के साथ. अगर पॉजिटिव वैल्यू आई तो मतलब इट्स लेस फीजिबल, इफ इट्स नेगेटिव तो मतलब मोर फीजिबल. यही हुआ ना?
हाँ.
ओके
ठीक है, और फिर वो एक और क्वेश्चन आता है कि टेम्परेचर चेंज करने से भी वो कहता है कि what happens if temperature increases, what happens if temperature decreases.
तो
तो
अगर
वो भी
टेम्परेचर नेगेटिव होता तो नेगेटिव पॉजिटिव बन
नहीं,
जाता।
टेम्परेचर नेगेटिव नहीं होता, टेम्परेचर इज इन केल्विन्स. हाँ, मेक श्योर you have to be careful, it's not 25, it's actually 298 kelvins. मतलब be very
275
careful.
plus 25
276
Kelvin में
C
convert
plus
hypothetically
20.
more feasible.
हाँ, मतलब let's assume we had a question. They'll ask what will happen if you do it at a high temperature. So what you're going to do is you're going to plug in the values. Okay, delta H in this case is positive. It's endothermic, right? But they already gave us that's positive. ये कोई जल्दी से बता दे, is this delta is positive or negative?
डेल्टा इज पॉजिटिव।
नहीं, क्या आ रहा है? I think it's coming out to be positive, right?
पॉजिटिव, यस सर।
Yeah, it's coming out to be
नहीं,
positive, right?
पॉजिटिव, यस सर।
Achha, so both of them are, so it's a positive value minus temperature multiplied by another positive value. So if I increase temperature, would delta G become negative or positive?
Negative, sir.
Negative, because there's one positive term and this term is actually negative because of the negative T. So one part is endo, the other part is exo. So if you increase temperature, so your exothermic term would become bigger and delta G would become negative and it would become more feasible. So that's the other type of question that comes. What happens if
temperature कम होगा उतना less feasible होगा।
हाँ, क्योंकि if temperature goes to 0, so I mean this term would, I mean let's say this term becomes very small. So delta G would be equal to an endothermic value. So that would not be feasible. ठीक है?
सर इस वाले का क्या आंसर होगा B1 से देखते हुए?
इसका?
हाँ सर, how do you
इसका क्या?
refer to B1?
Insoluble, why is it insoluble at 25
नहीं,
degrees?
वो तो बस feasible बताना है. You just have to calculate delta G, that's it. Delta G is going to come out to be a positive value and you're going to just say that it's unfeasible because it gives free energy is endothermic.
सही, okay.
मतलब वो देख लेते हैं. That's about it. कि इसका बस, which one is this? So it's just positive and it's not feasible, that's it. ये part.
सही सर।
चलो ठीक है, कल करते हैं यार.
ओके सर, थैंक यू।
हाँ जी, हाँ जी, अल्लाह हाफिज़. कोई क्वेश्चन है? मैसेज कर दो, बाज़ आपकी आवाज बहुत. February March कौन सा? 20 and question paper
4-2.
let's see. Assessment, which one?
Question number 3 है, इसमें डायग्राम ड्रॉ करनी है पूरी.
ये वाला?
Part 2. इसमें जब हमें वही नहीं पता E0 वैल्यूज, तो फिर उसके बगैर कर सकते हैं हम ये?
नहीं, you can do that because there are 3 types of electrodes, right? There's if you use a metal as an electrode, AU is a solid. So you're going to have AU as a solid metal electrode, and the AU 3+ ions would be part of the. They're going to be part of the solution. Okay, that's one electrode. The other one is aqueous and gas. So when you have a gas electrode, you need a gas jar, right? And the NO gas would be coming in, and the solution would be nitric acid, and you will add a platinum electrode.
तो सर how will we explain the electron flow if we don't know?
Huh?
Electron flow का कैसे बताएंगे?
At the moment, if you don't know the electrode E0 value, you won't be able to tell the electron flow. But they've told us that this one is 1.5 volts, right? This one is 1.5 volts. And did they give us draw a fully labeled diagram include? And they didn't ask for the electron flow.
Okay, ठीक है.
ठीक है. Because you can't obviously tell the electron flow because you have no idea what this is. Actually, you do. The question has NO and HNO3, right? So do we have this? It's NO. So it's this one, right? NO and HNO3.
जी मैंने ये वाली
So this one is 0.96. So the electron flow would be from negative to positive, so it's going to go in this direction.
तो लेबल में इलेक्ट्रॉन बताना जरूरी नहीं होता?
नहीं,
अच्छा ठीक है।
हम इस केस में you don't they didn't ask for that. They usually do ask for it specifically if you have to tell them. ठीक है, you just have to draw the labeled apparatus, that's it. चलिए और तो कोई चीज नहीं है।
सर थैंक यू।
चलिए ओके एवरीवन।
सर आप कल स्कूल में अवेलेबल होंगे?
मुझे तो आज भी किसी ने बुलाया था, आज भी कोई नहीं आया था। मैं हूँगा मैं।
अच्छा मैं आपको कॉल कर लूंगी।
ठीक है, मैं 11ish I might be there, ठीक है, लेकिन आप बता देना, ठीक है।
हाँ मैं भी उसी टाइम पे आऊंगी।
चलो ठीक है, लेकिन फिर मैं आने से पहले आपने वो कर देना, मैसेज या कॉल कर देना, ठीक है।
ओके सर, ओके अल्लाह हाफिज़।